Hello and welcome. This is Carsten Bott, EMC community member of the EMC Microsoft community. Today I would like to introduce you the EMC storage integrator PowerShell toolkit named ESIPSToolKit. Today we will focus on 3 actual storage provisioning tasks. The first task would be create a new storage LUN on an EMC storage subsystem, map that LUN to a host cluster to different cluster nodes, initialize that volume on the hosts, bring that volume to a cluster group and bring it online in the cluster. In the second part I will expand that LUN on the storage subsystem and expand the volume on the cluster itself. And the third part, it's the end of our demo and the end of the life cycle. I will decommission that LUN in the cluster and will also decommission that LUN on the storage subsystem. First of all, let's have a look at the failover cluster manager. As you can see, our cluster is named HV-SQL 2012 and it has actually 2 nodes. The nodes are running a bunch of groups like ESI Demo, SQL Server, MS SQL, that's the standard instance of the SQL Server, and another instance that's called SQL Server 2012 vPlex. If we have a look at the drives, at the disks, we have 8 cluster disks right now available in that cluster. One is in the available storage group, the others are in those both SQL Server groups, and the last one actually is the Quorum device. We have the same information with some more details in our EMC Storage Integrator UI. You can see all those 8 cluster disks, but you can also see the origin of those drives. So they come from that VNX 5300. They have a special LUN name like SQL Disk 4. This is the ID 18 on the storage subsystem with that worldwide name on the storage subsystem. But we leave the EMC Storage Integrator Management UI beside for a while because we want to focus on our PowerShell commandlets. The PowerShell commandlets are pretty powerful. For ease of that demo, I'm launching all the commands from a script in the Windows PowerShell integrated scripting environment that I have set to debug mode, so that every command that we are issuing gets highlighted, and I focus on those commands that I use to configure the storage. The display commands are just like grayed out. So first step is I ask for a new name of that LUN. That is the name represented on the VNX storage subsystem, and I will use the same name, as the volume label later on for that volume on the cluster. So I name it ESIPSToolKit Learn. So the first commandlet that we will use from our ESIPSToolKit is we will retrieve the information from our cluster with the commandlet get EMC cluster system and the name of the cluster itself. When we've done so, we will refresh the information of the cluster disks. So the first output, because PowerShell is an object-based scripting environment, we set the output, the members and the methods to a variable named $emccl. So the next command is I will just do an invoke to that emccl, which is called refresh cluster disk. That's a method inside our commandlets that refreshes the drives on the cluster. So we go out to the cluster and actually rescan all the drives to make sure we have the actual cluster drive information, the logical to physical mapping of the cluster disk to a host drive. This takes a few seconds, and after this is done, I just print out the necessary information. Also here in my PowerShell, I just give out the names of the cluster disk resource names. We have 8 cluster disk drives in here, and also the names of the available storage groups. We have 4 storage groups. One is named available storage, the ESI demo group, the SQL Server MS SQL Server group, and the SQL Server SQL 2012 vPlex group, which is pretty much similar to that what we saw in the failover cluster administrator. Remember, that came from an EMC PowerShell commandlet. Next, I will get information about my storage system VNX 5300 CCS0, and when I do this, I pipe this command because I want to update that EMC system. That means please give me the actual information, the actual configuration information of that storage subsystem into my PowerShell session, because we don't store this information on the host. We have to retrieve it for the session to make sure it's actual. When this is done, again, I set a new variable that's called $SSYS, which has the objects of the get EMC storage system VNX 5300 CCS0. Next one would be the same for the pools. We want to provision the new LUN in a pool named demopool0, so we must set this object to a variable named $pool because we need this later on. The next step would be we want to provision a new LUN in the pool $pool with the name we gave up front with a capacity of 1 terabyte, and the result of this new LUN will be an object in the variable $LUN. Actually, he's going out to the storage subsystem and is creating the LUN. This takes a few seconds. It's pretty much fast on the VNX. It's a SYN provisioned LUN, so we only allocate the amount of space that we need. Right now the task is completed, a new LUN has been created. So what needs to be done next? We have to set LUN access for our host. We do this by the commandlet set EMC LUN access, and we give it the name of the cluster. What he does, actually, he puts the LUN into the storage groups corresponding to the worldwide port names of the cluster nodes, and gives it a host LUN number. This is the host number 6, and it's actually the LUN number 77 on the storage. It has been unmasked to the cluster, and next task will be on the hosts itself. We want to identify that newly unmasked LUN on each of the nodes in the cluster. So we do this by find EMC host disk on the cluster. That means again we have to refresh the multipassing information on the nodes. For this we talk to a proxy service for the virtual disk service, a remote disk service, because we do it in a remote PowerShell session. It takes a few seconds. Sometimes we need to refresh the disk service and do the rescan attempt. We call that process LUN surfacing. When this is done and we have retrieved the actual information, we can start with our next step, that will be initializing that host disk on the cluster. So the newly found host disk will be initialized. For information, I just printed out that it is physical drive 14. On the active cluster node, we will set it to partition style GPT. Actually, this is the same as doing a disk part or a right mouse click online command in the disk administrator. So we initialize the disk, and after a few seconds this disk is online and initialized with partition GPT, partition style GPT. The next thing will be we just create a volume on that drive, format it, and give it a label with the variable of LUN name. I guess it was ESIPSToolKit _learn. So now we're going to provision the volume on the host. That one is actually having that drive active under control. This task is completed. I print out again some information. You see the host system global ID, you see the host volume identifier, as well as the size, the allocation unit, and the volume label. This disk is not mounted right now, and the next thing we do is we add this host system to the cluster. And we put it in a storage in a cluster group named ESI demo. While we do it, just have a look at the right side. the volume is first put into available storage. After this, we are taking it offline again because we need to move it to the cluster group ESIDemo. That's the normal process, and how you would also provision a standard volume, a standard task to a cluster. So you have to make it available in the available storage group and then move it to the actual group where it belongs. After this, the information on the cluster gets refreshed and this volume is added to the cluster. We see it here, it's a 1 terabyte volume. It's there, and the last thing we do is we refresh the disk information on the cluster to make sure we have the actual information, and then we are done. Now you see, as an output, I also printed out that we have right now 9 cluster disks, and the LUN ESIPSToolKit Learn has been created as cluster disk 9 in the cluster HV-SQL 2012 on node HV-SQL 2012 N1. And you see the same information over here in the cluster failover cluster administrator. I clear the screen right now, and the next thing will be I will expand that drive in the cluster. For this we have a commandlet that's called expand EMC LUN that gets fed with the actual LUN variable that we have got from the prior script, and the new capacity should be 4 terabyte or 4096 gigabyte. Right now he's extending the LUN on the storage subsystem. It takes a few seconds again. It's a pretty fast process because it's all thinly and virtual provisioned. And he returns. When he returns, I can then go out and find information of that volume on the cluster node. So I must make sure, I must identify the node on which that volume is currently online, because the next step will be I have to expand that volume on the cluster. So I've identified that one, and the next thing is the actual expand commandlet, which is expand EMC host volume, and as parameters I give the host system and the volume that I want to expand. And again, it might be possible that you see a short refresh in the cluster on the other side. He's extending the volume, retrieves the actual disk information from the disk service, does a refresh, and you see on the right side the information has changed. ESIPSToolKit Learn right now is 4 terabytes in size. Now that was pretty much fast. We can retrieve the same information from our EMC storage integrator management UI. If we go in the cluster and tell him to refresh, he's going out to each cluster node in that management console session and retrieves the actual information from that cluster. Now you see why it's important to always refresh that information, because while I'm doing a configuration, somebody else could have been done a configuration from another node, though this information always could change. And you see here the ESIDemo LUN right now is 4 terabytes in size. So as the last part in our demo, we will focus on the end of the life cycle of each drive, of each cluster drive. So that will be that we need to decommission that volume because we no longer need it in the cluster. It's a 3-step approach. The first thing is we need to remove that drive from the cluster system. For this we have a commandlet that's called remove EMC host disk from cluster. We give it the cluster name, and we give it the host disk, and we do the -force because we don't want to get asked for it. As you can see on the right side, pretty much fast, the drive is removed from the cluster itself. Right now the host is still seeing that drive because it's still unmasked to the host. So I have to set the LUN access to unavailable for both hosts in the cluster, and again I do it with set EMC LUN access and give it a LUN and the cluster system with the parameter unavailable. Takes a few seconds. We are masking the LUN from the initiators. And after a few seconds, the host is no longer able to see that drive. When that has been done, the last command will be remove EMC LUN with the parameter of the LUN and the -force, which actually removes or destroys the LUN on the storage subsystem. This is the point of no return. Actually, my data has been gone, and you can see it's no longer available in the cluster. And if I go to my EMC Storage Integrator Management UI and I do a refresh on that as well, he will remove that configuration information from the Management UI after the refresh, and the 4 terabyte drive has gone. Actually, it's already gone. He just needs to refresh that information, so he sees 8 cluster disks like we should have right now. It's the same information like we have in the failover cluster. I'd like to say thank you and goodbye for this short 15-minute demo of the power of the ESIPSToolKit. I hope you enjoyed the session, and just reach out for me for commands on Twitter. My Twitter tag is ESIPSToolKit. Thanks and bye-bye.